This is lesson 19. I will create and solve multi-step word problems from given tape diagrams and equations. So in this lesson, you're going to completely skip your journal because there's not going to be anything to put in your journal today. You're going to go directly to your problem set. So go ahead and get out lesson 19 problem set and let's get started. Okay, so you're going to notice, first of all, that it's going to look like I'm not giving you the problem set. But this is the very first question that is on your problem set. It's just a picture of a tape diagram, and we're giving you, or it's giving you this context. You've got to figure out from this tape diagram how to write a simple two-step word problem from the tape diagram below. So I want you to take a look at this tape diagram, and you'll notice that this is a single tape diagram, so we're not doing any comparing. We just have a total. Our total is 7,104, and we have three parts. We have 4,295, 982, and then we have part A. So they're giving us a context. This means we have to write a problem about people at a football game. Okay, so I'm going to go split screen here, and I'm going to type because typing would be much faster for me than trying to write this out. Okay, so I noticed that I have a total. So since my story says something about people at a football game, I'm going to start just like I would if I was given a word problem. Usually they give you the total first. So I will say there are, or no, let's say there were 7,104 people at a football game. So that's the total. So I have to come up with three different types of people. So since there are 4,295, I'm thinking since the football game has mostly lots of men like sports, so I'm going to say there were 4,295 men, 982 women, and some children. So notice I gave an exact amount of men, an exact amount of women, and then where it got to the next part where it says A, I just said some children. So I want them to solve for A. So I'm going to say, how many children were at the football game? Okay, so that's my problem. Now it says not only do I have to create, I also have to solve. So now I have to solve for A. So I'm going to come up here and get my pen. Okay, so I have to figure out, we've had several problems like this where we're given this total and then we're going to have to take away these two parts and whatever's left over is going to be A. So there's two ways to do this, but I'm going to go ahead and put the men and the women together. So I'm going to take 4,295 and I'm going to add to that 982. And that gives me 5,277. So this is how many men and women are at the game. So if I take the total number of people at the game, which is 7,104, and I subtract this number, what should be left over are the number of children. So I cannot regroup here. So I'm going to go over here. There's nothing to decompose. So I'll come over here to the hundreds. Now I have no hundreds, but I have 10 tens. But I still don't have enough to subtract here. So I'm going to have 9 tens, 14 ones. So I can subtract in the ones. I can subtract in the tens. I cannot subtract here. So I'm going to have to go over here and decompose 1,000. Now I'm ready to subtract. So I have 7, 2, 8, 1. So my answer is, I'm going to go ahead and type this too. My answer is there were 1,827 children at the football game. Okay, so on to the next problem. Go back full screen. So again, we're given another tape diagram and we're given a context. So we've got two houses here. So when you see two tape diagrams like this tells you that you're comparing something. And in this case, since we're talking about houses, I'm comparing the cost of one house to the cost of another house. And if you'll notice, I have this bracket with M. So what that means is we are trying to solve for the total of both houses together. So it looks like one house costs $215,554. The other house costs this much more than the other house. So let's get started on our story problem here. So again, I'm going to type. So let's say two houses were for sale. One house cost $215,554, and the other house cost $90,457 more. Now, since this tape diagram shows this bracket with the variable M, I'm solving for how much they are together. So my question is going to be, how much do both houses cost all together? Okay, so now I'm ready to solve this problem. So, first of all, I'm going to figure out how much the more expensive house costs. So if it costs $90,000 more, then that means I'm going to have to begin by adding $215,554 to $90,457. So when I add these together, I get 11, and I get 10, 6, 10. All right, so I get $306,000, $306,011. So this is how much the more expensive house costs. So if I was going to come over here and put in the tape diagram, I could write $306,011. So that's how much one house costs. But I'm trying to figure out how much both cost together. So this is how much one house costs. So I'm going to add to this the price of the other house, which was $215,554. So I'm going to find the total sum here. Okay, so I'll get $521,565. All right, so I'm going to type my answer here. Both houses cost $521,565 all together. All right, so we have two more problems to do. Let's take a look at problem number 3. So let's go back to full screen here so we can look at the problem. If you feel pretty comfortable writing your own problem, this would be a good time for you to go ahead and try. Your problem obviously is not going to be exactly like mine, but it should be very similar. So again, I have 3 tape diagrams. So I'm comparing three somethings. Now, the context tells me I'm comparing the weight of 3 different whales. So one whale is going to weigh 8,200 pounds. See how this box is smaller? So the next whale is going to weigh 3,500 pounds less than this whale, and the largest whale is going to weigh 2,010 pounds more than the first whale. So in order to write my story, I have to kind of think to myself, all right, I know I'm writing about 3 whales. Again, when I see that the question mark is over here, that tells me I'm trying to find the total. So when I start my problem, I don't know how much they all weigh together. That's what I'm going to ask. So I would say 3 whales were swimming in the ocean. I'm going to say that the 8,200 number is for the mother whale. Okay, so the mother whale weighs 8,200, and this is the abbreviation for pounds. The baby weighs 3,500 pounds less than the mother, and the father, which is going to be the biggest, weighs 2,010 pounds more than the mother. How much all three whales weigh together? Okay, so we've got the mother whale, the baby whale, and the father whale. Okay, so the first thing, I know how much the mother whale weighs. I've got to figure out how much the baby weighs. So if it weighs 3,500 pounds less, then that tells me that I'm going to have to use subtraction to figure out how much the baby weighs. So if the mom weighs 8,000, so I'm going to label this baby. Okay, so it weighs 3,500 pounds less than the mother. So I'm going to subtract here. I can subtract in the ones and the tens, but in the hundreds, I'm going to have to decompose and make this 12. So that gives me 007, 4,700 pounds. So this is how much the baby weighs. All right, so next I'm going to go to the father. The father weighs more than the mother. So this time, instead of subtracting, I'm going to add. It weighs 2,010 pounds more. So I'm going to add. So the father weighs 10,210 pounds. So if I want to know how much this is altogether, I'm going to have to add all three of these numbers together. So I'm going to start with the father, the mother, and then the baby. I'm going to add all these together. These numbers are pretty small, so it works out pretty easily. So I've got 4 plus 7, which is 11, 13. So I'll get 23,110. So now I'm going to answer this question. How much do all three whales weigh together? So I'm just going to say the whales weigh 23,110 pounds all together. Okay. All right, let's take a look at this very last problem. There's one more. Oops, I went too far, I think. Okay, so this time, this problem is just a little bit different. Instead of giving us a tape diagram, it's actually giving us an equation, and we have to draw the tape diagram. So we have to be able to interpret this math problem. So I have a total here, and then I have three parts. This is not a comparison problem. This is just three parts are equal to this one total. So when I draw my tape diagram, I've got my rectangle here, and then when I go back up here, I'm ready to label. I know what the whole is. That's what this equals. So I know that this equals 12,946. I know that one part is 5,233, and I know that another part is 3,094, and I'm trying to solve for K. Now, this one says, compare with your partner, then create a word problem that uses numbers from the equation. Remember to first create a context, write a statement about the total and a question about the unknown, then you can tell the rest of the information. So this doesn't give me a context. I get to create this totally from scratch. So I have to think of something that makes sense with these large numbers. Like it wouldn't make sense to say there were 12,946 crayons in a crayon box because you wouldn't have a crayon box that big. So I'm thinking people would be that much, dollars could be that much if you're talking about buying something. I'm thinking about something that would be fun for me to write about. So let's just say we just had fall break and a lot of people went to the beach. So let's use that as our context. Let's talk about people at the beach. There were 12,946 people at the beach. There were 5,233 women, 3,094 men, and some children. How many children were at the beach. Okay, so this problem, you're going to solve this problem exactly like you solved problem number 1. We have to take these two parts away from the whole. So I'm going to begin by putting these two numbers together and then subtracting the total away from the whole. So I'm going to start by adding these two numbers together. So I've got 5,233 plus 3,094. So I'm going to add this together. That gives me 8,327. So together there were 8,327 men and women. So if I take this number away from the total, I should be left with the number of children. So I have 12,946 minus 8,327. So I cannot subtract in the ones, so I have to decompose the tens, and that gives me 3 tens, 16 ones. I can subtract in the tens, I can subtract hundreds, but when I get to the thousands, I cannot subtract. So I'm going to have no 10,000s and 12,000s. Okay, so let's just subtract. So I get 9, 1, 6, 4. So there were 4,619 children. So now I'm just going to answer the question. I'm going to go ahead and type that since it's a little bit faster. So how many children were at the beach? I would say there were 4,619 children. This is a pretty tough lesson. Whenever you get ready to do your extra slip, it is okay to go back and take a look at your problem set and see how we wrote problems for some of these tape diagrams. So use that as a reference.